Hello student, good morning to all of you. Do you remember what were we discussing yesterday? I think we were discussing about the effect of electron donating group or electron donating substituent and what type of the product generally we are getting. Similarly, when the effect of electron withdrawing group, what type of the product generally we are getting, as well as we have learned why halogen shows unusual orientation, or the effect of halogen, why they are showing unusual orientation. So that type of the discussion we have seen, we have discussed in a previous lecture, in yesterday's lecture. So what we are going to learn today, look at here, what is this? Orientation and the synthesis. Orientation, what does it mean, and how it is helpful for the synthesis of particular aromatic compounds. So that is the topic of today's discussion. Do you know that in the laboratory the chemist always require or always wants single pure compound? Why does it so? Because if you are getting as a mixture of the product, there is lot of difficulty to separate the mixture from each other. By using different technique we can separate it, but whatever expectation is, whatever purity we require in a pure form, we are not getting as much as pure compound what we expect. And for that purpose the chemist always want to prepare or synthesize the organic compound that must be single product which is pure in nature. If the mixtures are obtained during the synthesis, then it requires separation, and during the separation whatever operation we are carrying out, we are not getting desired purity of that compound. There is a impurity contained, we are not getting 100% pure product which we expect. And therefore by keeping these things in mind, we can apply our knowledge to obtain or to get the single product. And that's why the topic we are discussing, orientation and the synthesis, we are going to apply that knowledge in which we decide to carry out the reaction in the laboratory to synthesize the pure organic compound, and for that purpose let us see here the condensation of order of reaction. Condensation of order of reaction. First one, condensation of order of reaction. Order of reaction. Condensation of order of reaction. Whatever thing we have just discussed, we are going to apply these knowledge here. The order of reaction in this particular synthesis. For example, let us see here, suppose we want to prepare the nitrobromobenzene. In a nitrobromobenzene, what we can do, what type of the reaction you can carry out, what kind of the order you are going to follow here, depending upon that you can synthesize or you can prepare the desired product. Let us see over here one of the example. Suppose you have a starting compound is a benzene, as we know that this is a structure of benzene, means it is your starting material. Now on that benzene, if you carry out the reaction, first one is a nitration, as we know that nitration, and as we know that nitration means what? You are using as a nitrating mixture over there. First one is a nitration. What is going to happen? That benzene reacts with nitronium ion and the product is a nitrobenzene. We are directly writing here is a product, we are getting as a nitrobenzene. This is the nitration reaction we have done here and we got the nitrobenzene, it is a product over there. The starting compound we have taken is a benzene, and when benzene is treated with nitrating mixture, the resulting product obtained is a nitrobenzene here. This is a nitrobenzene, as we know that. And after nitrobenzene, if you treat this nitrobenzene for halogenation, Br2 in presence of Fe or FeBr3, that FeBr3 is known as a Lewis acid. What it will do? The function of Lewis acid to generate the electrophile. Here the bromonium ion is formed, and as we know that here, because in a previous lecture we have seen, when the electron donating group present on the benzene ring, that direct, what type of that nitro group is, even though it is a electron withdrawing group, it deactivate all the position, because there are in monosubstituted benzene there are three positions. These are identical, they are termed as a ortho. These two are termed as a meta, and exactly para with respect to nitro group is known as a para position. When you carry out the reaction on nitrobenzene, the product exclusively gives or predominantly gives meta products, so that you are going to get over here is a meta bromo nitrobenzene. You can call it this one meta bromo nitrobenzene. Nitrobenzene, this is the product we got here. Only single product. Why only single product? The reason we already discussed, because if you draw the resonating structure of nitrobenzene, and you will see at ortho position there will be a positive charge, means the position, ortho position and the para position is strongly deactivated due to the minus I inductive effect and the minus R inductive effect. Only the possibility of attack of electrophile, this step is difficult. Why it is difficult? That the reason behind it, that we will going to learn while studying the mechanism of the nitration in detail. Here you just remember, because here we are talking only the orientation, means that that nitro group is directing the incoming group, means it is a meta directing, and therefore at meta position we are getting as this compound, means the chemist will prepare the compound. What kind of the compound he want to prepare or he want to synthesize in the laboratory, accordingly he can follow the step. Suppose the same reaction first is carried out. First one is a bromination, suppose as a bromination, and as we know that bromination first, this Br2 in presence of FeR Al Br3, which is a Lewis acid, what you are going to get? The same starting material, but what we are doing here, we are adding the first one, we are carrying out the reaction. First one is a bromination, and after bromination yield the product is this one bromobenzene. What the product we are getting? We are getting as a bromobenzene over here. The name of this compound is a bromobenzene. Look at here. What we did, we have taken as a starting material is a benzene, and that benzene, if you add first step is a nitration, we are getting as a nitrobenzene. If you carry out the reaction, first one is a bromination, we will get as a different product, that is a bromobenzene, and next one is a nitration. If you do the nitration reaction over here, what do you get? Now as we know that this group directing the what type of the product they are going to produce. Here look at this NO2 group is a director. What kind of the director it is? It is a meta director, and that's why we are attach of Br at a meta position, which is a exclusively product we are getting. But here look at the halide group. Now it can direct the incoming group, and now as we know that bromine atom is unusual orientation, because bromine atom are electron withdrawing group, minus I inductive effect, and minus I inductive effect, so that the reactivity of that group is decreased over here, but the Br having as a lone pair and which can show as a plus R effect, and plus R effect controlling the orientation of the incoming group, and that nitration group is at ortho and the para product. We are getting here the mixture of the product over here. Here is a Br here, and here nitro group at ortho position NO2, and another product we are going to get over here, this one which is Br, and this one is a NO2. Mixture of the products we are getting. Once the mixture of products are obtained, then there is a problem for separation. It requires a separation, and separations are carried out by using as a different separation techniques are there. So this one is called as ortho bromo or ortho nitro bromobenzene, or what we can call it as a ortho bromo nitrobenzene, and the name of this compound is a para bromo nitrobenzene, para bromo nitrobenzene. This is the name of that compound. I think with this we have seen how the condensation of order of reactions are taking place. This is the example when benzene is first treated with nitration. So depending upon what type of the product chemist want to prepare, accordingly he can he can carry out the reaction in this order. If he want the meta bromo nitrobenzene, first one he should first one is a nitration followed by the bromination. He will get the desired product. Suppose he want as a para bromo nitrobenzene, at that time this type of the orientation, this type of the knowledge we can apply for obtaining the desired product. Suppose it's a bromination first, you will get as a bromobenzene, and followed by the nitration, we will get the mixture of the product. Once the mixture of the product, and there may be as a what we can call it as a competition between these two. One is getting in a minor and one is a major. So this, depending upon the solubility factor, we can separate it by fractional crystallization, or if those are the compound we are getting in a, suppose as a liquid, there is a large difference between ortho and the para product. So by using as a fractional distillation, we can easily separate this type of the mixture in a pure para compound, or what we can require as a ortho isomer, para and the ortho isomer we can easily separate by using these two techniques, either by fractional crystallization or either by fractional distillation. Fractional crystallization means what, and fractional distillation means what? Fractional crystallization is nothing but as it depend upon the solubility, and generally the para molecule is which is a symmetrical, it is what we can call it, the solubility of that symmetrical molecule is less as compared to the ortho, and therefore they get solidifies, they get crystallized first, and by using as a fractional distillation we can easily separate these mixture from each other by using as a fractional crystallization. That is called as a fractional crystallization. Another word I am using over here is the fractional distillation, and fractional distillation means your compound are in a liquid forms are there, and then you can use as a fractional distillation. And in a fractional distillation there is a large enough difference between their boiling point, and therefore by using as a fractional distillation, a fractional what we can call it as a fractional distillation, we can separate this type of the compound from each other. Suppose as the mixture is a solid and liquid, only just as a ordinary filtration you will get as a solid and the liquid get separated from each other. These are the different technique used for the preparation of what we can call it as a separation method for obtaining as a pure compound. So this is there. Now the second point is a condensation of one functional group, conversion of one functional group into another. Second point will be this one, conversion of one functional group into another functional group. Conversion of one functional group. Second point will be conversion of one functional group, functional group into another functional group, FG means functional group. So that is the next point of discussion. Suppose if synthesis involve conversion of one functional group into another. For example, let us see, I am going to clarify or going to explain the conversion of one functional group into as another functional group. Here also you can follow the order of the reaction. Let us see here the starting compound I am taking over here is this one. As we know that this is the molecule. Do you know the name of this molecule? Yes, the name of this molecule is a toluene, right? The name of this molecule is a toluene, and if this toluene first one is carried out with first one is a oxidation is carried out here. First one is a oxidation, suppose oxidation reaction. Then what you are going to get? Oxidation means alkaline potassium permanganate. You can use here alkaline KMnO4 potassium permanganate, which is a suitable reagent used for the oxidation of such type of the side chain get oxidized, and we are resulting compound is obtained is a benzoic acid over here. So what is happening here? This group, methyl group, hydrocarbon group is mainly converted into this one, and this is known as a benzoic acid. This one is known as a benzoic acid, right? Why we got as a benzoic acid? When we carried out this reaction, first one is oxidation, and then further treated with the nitration reaction. Nitration reaction, as we know that concentrated HNO3 plus concentrated H2SO4, the nitrogen. Now again here is a carboxylic group, and this is carboxylic group is a director. Director means which it is deciding the group where it is going to attach. So here this is the nitrating mixture, means nitronium ion going to attach to the aromatic ring, but at which position it is going to attach? First one, because it is an electron withdrawing group. Carboxylic group is act as a or serve as a electron withdrawing group, and therefore the product is obtained as a meta product, as we know that. And here you are going to get C double bond OH, and at meta position NO2 you are going to get as a meta nitrobenzoic acid. This is called as a meta-nitrobenzoic acid. Meta-nitrobenzoic acid. So this is the first. If you do this one, you will get as a this type of the product. Suppose if you carry out, first one is a nitration over here, nitration reaction. Nitration. First step is a nitration, means nitrating mixture concentrated HNO3 and plus concentrated H2SO4. What you are going to get? First one, you are going to get the mixture of the product over here, right? As we know that this group is a electron donating group, and when it is electron donating group, the nitration first takes place, which produce orthonitrotoluene, as well as second product will be this one CS3, that is a para-nitrotoluene, right? Para-nitrotoluene. The first product will be the orthonitrotoluene. This is orthonitrotoluene, and this is called as a para-nitrotoluene. Para-nitrotoluene. This is the second product we got. Para-nitrotoluene. Either you can say it is a 2-nitrotoluene, or you can say 4-nitrotoluene. But simply, and now if you carry out the oxidation reaction here, oxidation, what you are going to get? This group is going to oxidize, and you will get the compound over here, this one, C double bond OH, and orthonitrobenzoic acid, as well as we are going to get in this case this one, that is a NO2 over here, and NO2, and here COOH. This is a para-nitrobenzoic acid. This is the product we are going to get. So depending upon which product you want to prepare, so accordingly you can plan your synthesis by following this type of the order, and you will get the desired product. So in this way, I think we have seen this is the orientation and the synthesis, and by taking as a suitable two example, because only two type of the groups are present on the benzene ring. One is either electron donating group, they are the orthopara director, or second one is the electron withdrawing group, and they are the meta director. Accordingly, we can plan our synthesis and we will get the desired product. Just now we have seen two are the suitable example. I think with this, let us stop today here. Remaining, that is a nitration reaction in actual, we will see in detail in the next lecture. Have a nice day. Thank you.